before we get started to look at all the capabilities of JAX and Flask, first just look at what JAX and Flask are and some background into this and why this might be useful for you in your deep learning journey. Before we get started, let's get some background and then move into the actual use cases on GPU, TPU and CPU. But first let's learn what JAX is. So JAX is an autograd and an XLA brought together for high performance numerical computer and machine learning research. It provides composable transformations of Python plus NumPy programs, which is differentiate, vectorize and parallelize just-in-time compile to TPU and GPU and more. But in the layman terms, if you want to understand, JAX is a NumPy on CPU, GPU and TPU with great automatic differentiation for high performance machine learning research. And what is XLA? Since we have used the term XLA in the previous one, we also need to get an idea what XLA is. So XLA is accelerated linear algebra. It lies at the foundation of what makes JAX so powerful. This was developed by Google, I think, in 2018. And XLA is a domain-specific graph-based just-in-time compile for linear algebra. So using XLA, it improves the execution speed and lowers memory usage by fusing low-level operations. And this is basically what you can understand, what JAX can be useful. So JAX is a high-performance numerical computation library which incorporates composable functions, transformations. As we can see, deep learning is just a small set of what JAX can do. It can do just-in compilation, automatic parallelization, vectorization and differentiation. So if you have to understand at a higher level, just think with JAX you can do JIT, which is just-in-time compile, automatic parallelization, vectorization and differentiation, which are mostly scientific computing and function transformations. So why do you need to care about JAX? Or why should you even take the pain of learning JAX? It's all about speed. This is the universal aspect of JAX that is relevant for any use case. And before we go into this, you can see from this, I'll just show you what we can do. So time to calculate sum of matrix power in NumPy takes about 400 milliseconds. In JAX, it takes a couple of less time. So let's go into this example, whatever I showed. This is the basic NumPy code I have, wherein I'm just doing an operation. You can see the time here. And you will have access to this Google Colab and you don't have to type anything. You can just go to my GitHub and source this and use it. So you don't have to bother typing anything. And let me also run both of them. So we'll get to know the time. Okay. So it took 581 milliseconds and 55.8 milliseconds per loop. Here it's 225 milliseconds. And what we now need to look at is, if you go at this and look at what we have used here. Okay, so let me go into this one. So if you look at view resources, if I look at change runtime, I was using a CPU. So let's change it into TPU and see if we are able to do much better. So whatever I ran it initially on the CPU, now I'm running it on the TPU and you basically see a better performance in time here. And similarly, you can play around with different variants of TPUs here and see how the performance is better than what it's actually doing. So here it took 618 milliseconds. Here it took 3 milliseconds. So you can see the time. It's roughly, as we can see from the slides, it's insanely faster like roughly 33 or 40 times faster than doing it on a TPU. So that's what I wanted to show you here. And similarly, if you go back, you can try it out in CPU and also TPU v2. And that's what this computation is helping you to understand. So now let's move back to the last one. Why JAX may be useful for you, or if you are considering using JAX for your deep learning, why would you use it? So NumPy is one of the fundamental packages for scientific computing. NumPy with pandas is mostly used in PyTorch, TensorFlow, or any other framework, but it is only compatible with CPU. JAX provides an implementation of NumPy with a near identical API that works for both GPU and TPU extremely easily. For many users, this alone is sufficient to justify the use of JAX. XLA, or the Accelerated Linear Algebra, is a whole program optimizing compiler designed specifically for linear algebra. JAX is built on XLA, raising the computational speed ceiling significantly. JAX allows you to transform your own functions into just-in-time compiled versions using XLA. This means you can increase computation speed by professionally orders of magnitude by just adding a function decorator to your computation functions. And auto differentiation. So JAX refers to as AutoGrad and XLA brought together, the ability to automatically differentiate in crucial areas of scientific computing, and it provides powerful auto differentiation tools. We are going to look at each one of this in detail in the follow-up lecture. Here it's just giving an overview of why you should consider learning JAX. So deep learning, while not a deep learning framework itself, certainly provide a more than sufficient foundation for deep learning purposes. So there are various libraries which are built on top of JAX for deep learning, which is Flask, Haiku, Elgi. And if you click on these links, it should take you to your GitHub profile with more implementation on how to use it. We'll try to cover it in the later lecture, but for now, just understand this exists and you can use it. And general differentiation paradigm. While it is certainly possible to use JAX in order to build and train deep learning models, it is provides a framework for general differentiation programming. This means JAX can exploit the prior knowledge in a given field through decades of research by using a model-based machine learning approach to solving a problem. So in the follow-up lecture, I will go into more details of each one of them and how to use JAX in vectorization, differentiation, and parallelization. And let's look at it in the next lecture. Thank you for joining.